The advanced lecture, Formal Methods in Security, is about the analysis of problems in computer security with formal methods, that is, with mathematical precision. We will teach you techniques to design and implement a secure system, secure programs running on the system, and secure protocols that are implemented in a distributed fashion by various programs on various systems. To this end, the lecture is split between 3 domain experts: Hamid Nemati, who will treat system-level verification, Marco Vasena, who will treat language-based information flow control, and myself, Robert Künnemann, who will treat protocol verification.
In the first part of the course, we will study information flow control techniques that track how data flows in a program to enforce data confidentiality and integrity. We will discuss both static and dynamic IFC techniques based on security type systems and taint tracking, as well as techniques that track data flows in a program at a different granularity, for example, per program variable or per program block. Finally, we will see how programming language principles can be applied to formally verify that these techniques enforce security.
In this part of the course, we will learn about verification of low-level system software like microkernels and hypervisors. In practice, verifying these systems is very challenging. We will see different strategies used in practice to make verification of such systems tractable, like abstraction to remove unnecessary details from the system model, decomposition to split system verification to smaller parts, and refinements to make verification easier by introducing more complexity step by step. Finally, we will see how to combine formal methods and fuzzing to validate systems that their complete verification is not possible.
Protocol verification assumes that the cryptography is perfect and tries to ensure that it is used correctly. It is not about defending against super smart mathematicians exploiting biases in key streams, but about equally smart hackers confusing one party about the state of another party. We will discuss how to get from the Alice and Bob notation to a minimalistic, precise specification of the protocol and its setup. We will also discuss how to formulate our security requirements and how to verify that these requirements hold for a given protocol, using tools that have by now reached an impressive degree of automation.